This is one of the most important pieces of math. It's called the Fourier transform, and it is critical to modern technology. Without it, our world would look vastly different. Electronic communication relies on this math to compress and encode signals, meaning that without it, we wouldn't have TV, mobile phones, or social media. It's used widely throughout engineering as a key tool in the process of creating everything from skyscrapers to microchips. It's also used heavily in physics and plays a crucial role in our understanding of the universe. So what is it? While this formula looks quite complex, what it does is actually quite simple. The easiest way to understand it is through sound. Sound is essentially vibrations that propagate through the air as waves. These waves take on different forms for different sounds. The key to the Fourier transform is that any sound, whether it's a key being played on the piano, the rumble of an engine, or the sound of someone speaking, can be created by taking a bunch of pure tones like this and summing them together. The Fourier transform is a mathematical function that takes in some signal, in this case a sound, and then returns all of the tones needed in order to create that sound. You can think of this as a machine that listens to a song on the piano that tells you all of the keys that are being played. This is actually one of the many applications of the Fourier transform. Here's the waveform of the song Happy Birthday, as well as its spectrogram, which is a visual representation of the Fourier transform's output. In this spectrogram, you can clearly see the structure of the song. The data before the Fourier transform has been applied is called the time domain, and after the Fourier transform has been applied is called the frequency domain. The frequency domain is useful because it allows you to see patterns that would otherwise be invisible, like the melody in this spectrogram. It can be used to analyze vibrations inside of heavy machinery, detecting faulty parts and dangerous resonances, or to analyze radio signals, picking out useful data from vast quantities of noise. Even this video uses the Fourier transform to remove data imperceptible to humans, compressing it to a size that can be transferred over the internet. Without the Fourier transform, you wouldn't be able to watch this.